Hello there, welcome to my channel. Okay, in this video I'm going to explain to you about the chemistry paper 2, the 23 October November 2021 paper. The time duration for this paper is 45 minutes. Okay, let us move to the first question. Okay, number 1, Brownian motion and the diffusion of the gases provide evidence for the particle nature of matter. Which row identify as example of a Brownian motion and how molecular mass determines the rate of diffusion of gas molecules? Okay, for your understanding here, the more heavier, okay, this is the RMM or RAM, okay, the RMM, it is more heavier, it will become much more slower in the rate of diffusion, okay, slower rate of diffusion. So let us look at one by one here. Okay, pollen grain in water are seen to move randomly. Okay, and this is the same for this B. And C, salt diffuse faster in hot water than in cold water. This is a rate of diffusion. So they have two examples over here. Let us look at diffusion part. Heavier gas molecule diffuse more quickly. Lighter gas molecules diffuse more quickly. So your answer here should be lighter gas molecules diffuse more quickly. Alright, so this is wrong. And we have, okay, for the particular nature of matter, alright, they want an evidence. So the best evidence here will be pollen grain, because pollen grain can be seen in a microscope. However, for salt we have a very hard time to see their molecule movements. Alright, so the B is the one, the best answer over here. Okay, now let us go to the second question. Okay, now number 2, a student put exactly 25 centimeter cube of dilute hydrochloric acid into a conical flask. The student added 22.5 gram of solid sodium carbonate and measure the change in temperature. So which apparatus does the student needs to use? Okay, obviously we need to have a balance for this. Okay, balance to measure the mass, and we need to have a thermometer. Okay, thermometer, and we also need something to measure this 25 centimeter cube of dilute hydrochloric acid. So for this small amount we have to use pipette, alright, and not the measuring cylinder. So we have to use pipette, so which gives, there is no time over here, so stopwatch is not necessary. So here we have balance, pipette, and also thermometer. So your best answer here will be C. Okay, now for question number 3. A student separates sugar from pieces of a broken glass by dissolving sugar in water and filtering off a broken glass. So this is filtrate and this is the residue. So what is the filtrate? So filtrate only contains the sugar solution. Okay, sugar solution. If you want to have a pure water, then you have to do at least a simple distillation process. Okay, same like a salt water. Okay, now we move on with question number 4. Okay, number 4. A nucleus of a particular atom consists of 19 particles. 19, and this is nucleus. Nucleus is 19. Okay, this is the X. 9 of them are positively charged and 10 of them are uncharged. So which means the proton number here is proton number here is 9. Electron should be the same because this is an atom they mentioned. Okay, and neutron should be 10 of them, so here should be 9. Which statement about this nucleus is correct? So proton number is 9, nucleon number, okay, this is nucleon, yeah, this is proton, electron, neutron, so this is nucleon, big N, nucleon. So nucleon should be 19, so this is wrong. Nucleon number of 9, this is also wrong. Proton number of 10, so this is also wrong. So your best answer here will be C. Okay, which description of brass is correct? So brass is an alloy. Okay, brass is an alloy. It's a mixture. So they have copper and zinc. Okay, copper plus with zinc. So your answer here is A. Definitely is A. Okay, now we look at question number 6. Okay, now here let me try to make it bigger. Yeah, okay. So now group 1 element combines with the group 17. Okay, this is a group 17 and forms an ionic bond. Which row shows how the electron structure changes? So group 1, they'll form a metal. They will donate 1. Okay, they'll donate 1 electron. So let me make it a bit smaller so I can do an equation here. So group 1, okay, so they will donate 1 electron. However, group 17, they will accept 1 electron to form the positive ion. Okay, so this is the difference. So before bonding, they must have 1 electron. Okay, 1 electron. And after bonding, they have to donate. So this is correct. And before bonding here, they must have 7 because it's group 17. So they must have a valence electron of 7. And they will add 1 after the bonding and they will become 2.8. So this is the best answer here. 6 is C. Okay, now state number 7. Which statement describes an attractive force between molecules? Okay, attractive force between molecules here, they will be referring to covalent bonding. So it is you should have the answer. Okay, look at ionic bonding. Ions, anything to do with ions over here is wrong. So we have to look at answer A or C. So here we have a strong covalent bond which holds molecules together. And C is a weak force formed between covalently bonded molecules. Okay, so here, so they're asking for attractive force between molecules. So which means that, let's say we have 2 molecules over here. Okay, so inside is a strong covalent bond. Okay, inside is a strong covalent bond. So when you're talking about attractive force between molecules, which means the forces over here between the molecules. So this is normally is weak. This is what we call as a van der Waals force. Van der Waals force. So this should be C. They have a weak force formed between the covalently bonded molecules. So this is what they are asking for. Okay, now let us go for number 8. Which diagram shows the outer electron arrangement in a molecule of a carbon dioxide? Okay, for carbon dioxide. Okay, now let me draw the Lewis structure here. Okay, so this is Lewis structure, Lewis diagram. So we have a carbon dioxide. So carbon is group 14. So they have a valence electron. So we just look at valence electron. So they have 4. Oxygen is 6. So we have to look at the single one, okay, carbon, and put it in the center. Oxygen in between the oxygens. Okay, now you need to have 4 electrons to be stable, and here you need another 2 more, right, to be stable. So what we can do here is we put the carbon 4 electron in this side, okay, and then for carbon we will do it like this. So you have 6 of them. So at this part here you have the double bond, okay. So this is for the oxygen, this is for the oxygen, and this is for the carbon. So each of them they already secured 8 electrons bonding. So here we have a double bonds. Okay, so this is the Lewis structure diagram for carbon dioxide. So let us have a look with the answer here. So your best answer here could be, this is wrong, this is wrong, this is wrong, because here we can see only 2 electrons. So this is much more better. So we can see there's a 4 here. So your best answer here will be A. Okay, now for number 9. Aluminium oxide is an ionic compound containing aluminium ion and also oxide ion. Aluminium hydroxide is an ionic compound containing aluminium 3+ and also hydroxide ion. In which row are the formula of the aluminium oxide and aluminium hydroxide is correct? So when we add it on, here you have aluminium 2, oxygen 3. This is for aluminium oxide. For aluminium hydroxide, so please remember this 3 will go down here, and make sure you have to put the bracket and put the 3 over here. Okay, so this is the very basic question, and your answer here will be A. Okay, now move for number 10. Okay, for number 10, evaporation is observed at the negative electrode, which is cathode, during the electrolysis of a concentrated aqueous sodium chloride. Okay, concentrated aqueous sodium chloride, we have NaCl. Okay, now we list on with the ions. We have this with hydrogen, chloride, and hydroxide. So over here, both of these will go to cathode. Okay, this one will go to cathode, and here will go to anode. Okay, so what happened at the negative electrode, which is the cathode? If you look at the electrochemical series, okay, electrochemical series, the hydrogen is the most lowest, okay, compared to the sodium. So we will have, it accepts electron at cathode and it will form hydrogen atom, and eventually it will be combined with another hydrogen to form a hydrogen gas. So here we have here hydrogen. Okay, so this is for number 10. Now let us look at number 11. Okay, now for number 11, the energy level diagram for a chemical reaction is shown below here. This is energy, this is the progress of reaction, reactant, product, and let me list down some more. Okay, here will be the energy changes. So in this case, it is endothermic because it's rising. Okay, so you have a positive here, so this is endothermic reaction. And if you look at this, this is the activation energy. Okay, this is the activation energy required by the molecules to produce the product. Okay, now which statement about this reaction is correct? So if you look at it, it is endothermic. So endo we have 2, and energy is given out to the surrounding. If it's given out, it is exothermic, so which is incorrect here. So energy is taken in from the surrounding. Yes, this is correct. So 11 is boy. Okay, we move on with number 12. So number 12, chlorine react with the ethane to produce chloroethane and also hydrogen chloride. Okay, so this process is exothermic. Okay, now this is the bond energy shown in the table. So now I'm going to do a small calculation over here. For this reaction, the reactant, right, they need to absorb energy. They absorb energy to break the bond. So let us calculate this. CH. Look at here. 1, 2, 3, 4, 5, and 6. So here we have 6 times 410. Multiply with 410. Then we look at others. Okay, carbon to carbon, we have only 1. So which is a 350. Chlorine and chlorine. So here we have chlorine and chlorine 240. Okay, now we add on all the values over here. So I'm getting here about 3060. So same thing, we are going to do it at this site, but this site is different. They will release the heat. Okay, they will release the heat to form the bond. Okay, this is to break bond. This is to break the bond, which is endothermic, and here will be releasing the heat to form the bond. So here we have chlorine to hydrogen. Sorry, this is carbon and hydrogen. Carbon to hydrogen. 1, 2, 3, 4, 5. So we have 5 times 410. Carbon to carbon is 350 over here. And hydrogen and chlorine, we have 430. And lastly is this, carbon and chlorine, we have here about 340. So we add on both of this. So here we have about 3170. So this is basically it's a negative value because it is releasing the heat, and this is a positive energy because it's absorbing the heat. So now we have to plus both of this. Okay, take this and plus with this. So here you'll be getting about, so I'm getting over here about negative 110. Okay, oops, I think that I missed some numbers over here. Hydrogen 10. Let me just give me a few moments. Let me check this. Hydrogen, carbon 430, carbon 300. Okay. Sorry guys, it's my mistake. Here should be 3050. Okay, 3050. So which makes sense for negative 120. Okay, so this is your answer. Your answer is boy over here. Okay, so I hope you can understand this question. So now let us move on with question number 13. Okay, number 13. What is the concentration of solution when 31.8 gram of sodium carbonate is dissolved in water to make a solution of a 250 centimeter cube? So we have to convert this sodium. Okay, sodium, the RAM is 23, carbon is 14, oxygen is 16. Okay, so we have to take this and divide with the total RMM. So 23 times with 2 plus 14 plus 16 times with 3. So here we have 3 oxygen. So if we add on all this, we will be getting 48. So it's about 110. Okay, 110. So which gives you 0.294444. So this is the mole. Alright, so to get the concentration, we need to have it is the concentration mole divided by the volume. So here mole is 0.294 divided by 250 divided by 1000. Okay, so we have to change this into dimetric cube as well. That's why I divided with 1000. So I'm getting here the answer of 1.177 mole dimetric cube. So we can simplify this as 1.2. Okay, so this is the answer for this solution. And for number 14, a fuel cell is used to generate electricity. Which chemical are used in the fuel cell? So fuel cell will be hydrogen and oxygen. So they will have a combustion and produce the water. This is the waste and will be recycled again. Okay, so hydrogen and oxygen. This is your answer for number 14. Okay, for number 15, sulfuric acid is manufactured using a contact process. One of the reaction is shown below. Okay, this is the condition. This is the process where we need all the pressure, temperature, and also the catalyst. Okay. Statement 1. Equation has more molecules on the left hand side than on the right hand side. This is exothermic. Okay, using a high pressure shift the equilibrium to the left. Higher temperature increases the rate of reaction. Increasing the temperature shift the equilibrium to the right. Okay, let me explain to you in this small table. Here's the endo and exo, temperature and also the pressure. So for endothermic, we have to increase the pressure while reducing increasing the temperature and reducing the pressure. Okay, that's what will makes it shift to the right. However, for exothermic like this, increasing temperature doesn't make sense because it will release more heat. So we have to reduce the temperature and increase the pressure, and it will shift to the right. So if you look at all the statements, increasing pressure shift the equilibrium to the right. This is exothermic, so which is not right. Okay. Now look at number 2. Higher pressure shift the equilibrium to the left, so which is not right. So this is also wrong. Statement 2 and 4. Now number 1, the equation has more molecules on the left hand side than on the right hand side, which is true because this is the reactant and this is the product. And statement number 3, higher temperature increase the rate of reaction. This statement is different from this statement because this one is like a more to general. Okay, so your best answer here will be 1 and 3. So which is statement 1 and 3 are correct, B. Okay, now let us look at number 16 here. So for number 16, iron 2 chloride solution react with the chlorine gas. The equation is shown below here. Which statement about this reaction are correct? So we have iron 2 reduced to iron 3. This is not right. This is wrong. It should be oxidized. So number 1 is wrong. So confirm A is wrong. And chlorine act as a reducing agent. Chlorine is supposed to act as an oxidizing agent because it helps oxidizing this. Okay. So this one should be oxidizing agent. Now look at number 3. Iron 2 plus iron each lose an electron. Yes, it's correct. They have to lose one electron in order to form 3 plus iron 3 plus. Okay. Number 4. Chloride molecules are reduced to chloride ion. So this is correct. They are reduced. So 3 and 4 is correct. So your answer is donkey here. Now let us move to question number 17. Okay, number 17. Excess dilute hydrochloric acid is added to equal mass of powdered calcium carbonate in 2 separate experiments. Okay, 2 different concentrations of acid are used. The temperature in both experiments is the same. The result shows the change in mass of the reaction flask measured over time. So this is the results. Let me make it slightly bigger. Okay. So here is a mass of a reaction flask. And remember the acid is in excess. Okay. Acid is in excess. So y is the rate of reaction for 1 mole dimetric cube of a hydrochloric acid slower, because you can say the collision energy okay, now we're focusing over here. So the collision energy and we have a collision rate. So collision energy, no matter like what is the concentration that we are going to use, the collision energy remains the same. Okay, but the collision rate will differ, slower or higher. So the more concentration, we will have a higher collision rate, and lower concentration, we will have a lower concentration rate. So should be D as your answer. Okay, numbers 18. Basic oxide are neutralized by acidic oxide. Which element forms an oxide that neutralizes calcium oxide? So calcium oxide is a group 2, right? So this is an alkali. So we need something to do with acidic. So magnesium is a group 2 and this is a group 1. So both of their oxide will form an alkaline. So it doesn't make sense to mix with this. Hydrogen oxide will form water. So your best answer here will be sulfur. Sulfur is a group 16 and their oxide is much more acidic. Okay, so 18 you have a D as your answer. Okay, now we move forward with question number. Okay, for 19, 4 solid oxide are added to dilute hydrochloric acid and aqueous sodium hydroxide. Which row describe amphoteric oxide? Amphoteric means it can act as an base and also as acid. So you will have a reaction for both. So your best answer here will be an A, because they can react with hydrochloric acid, at the same time they can react with a sodium hydroxide. Okay, for 20, which row describes an acid and oxidizing agent? Okay, remember acid, it is a proton donor. Base is a proton acceptor. Okay, proton acceptor. Okay, and then at the same time, if you look at here, oxidizing agent normally they will be reduced. Okay, if the certain element is being reduced. Okay, example, we have chlorine. Okay, chlorine is chlorine at this one, and then they'll accept electron to form chloride ion. So this is a reduction, right? It's reduced. It is reduced. So what happened here? They will accept the electron. So your best answer here will be, for acid, is proton donor, and oxidizing agent here will be electron acceptor. So your answer here will be C here. Alright, so this is for number 20.